work some projects about the trench technologies. If you're ready, I'll begin. For the audience, I would be glad if you come closer. If possible, please, also to the center, sir. Thank you, shukran. I tell about especially trenchless and innovative infrastructure system and projects we have done. Istanbul Water and Sewerage Administration was established as a name ISKI in 1981. And ISKI, one of the largest water and wastewater utilities in the world, shared its knowledge and experiences with 70 countries. Duties of our ISKI to provide water, to collect rain and discharge wastewater, to protect water resources. In addition, we should also say providing of public services uninterrupted and ensuring subscribers' satisfaction. You'll see at the table key figures, our key figures. We have over 6.8 million subscribers in Istanbul with a population of approximately 16 million people. We provide 3,024,000 meter cube water daily to all the people of Istanbul. I want to summarize only if we say summarily, rehabilitation with CIPP and fall down form techniques started in 205 and continues to this day. Wastewater tunnels lines are continued to be constructed since 1995. And also we'll tell about some techniques. Congress Fair and Educations, organizations, you see our Congress Fair and Educations about trenchless infrastructure systems. As a public institution, we participated in the Nordic and Water Loss Forum exhibition organized by Akatet. Maybe you know Akatet, Mr. Yasin, tell about later, maybe. With the project we presented, we won the fight against water loss leakage award. Trench technology's effects or benefits, a lot of benefits, we think. Many people has some thoughts, maybe. We can determine the effects of the trenchless technologies. The main detail as follows. These are economic, innovative, environmental, and safe. And also there are a lot of social effects and economic effects. At ISKI, as you see at the screen, we are using now three rehabilitation techniques. At ISKI, these are fall-down form and CIPP and hose lining for using the pressure lines, especially. General aims of rehabilitation, our viewpoints and experiences, I can say, by using this technology instead of open excavation in important city center areas, natural and historical sites, with heavy traffic, the streets and streets is heavy infrastructure, extending the economic and physical life of the pipeline, completion on the project by covering the existing lines with rehabilitation material in a short time, in minimizing possible failures by renewing infrastructure system, reducing operation costs of infrastructure systems, ensuring the security of infrastructure systems against possible earthquakes or soil movements or disasters, And also ensuring customer satisfaction with the activating of the infrastructure facility in a short time. What is the technical aims of the rehabilitation? Ensuring the safety and strength of the pipeline as a single piece from start to finish. Elimination of fractures, cracks, and leaks in pipelines and ensuring the tightness of the pipeline. Increasing the resistance and flexibility of pipelines against external loads, for example, earthquakes, landslides, and any dynamic loads. Increasing the resistance and flexibility of pipelines against external loads. Yes. Obtaining a smooth and smooth surface. Increasing the wear resistance of pipelines against corrosive environments and fluids. And also preventing the anxiety of the roofs. And the ingress of the water from outside into the lines. Fold and form technology in Asian sites, 160 kilometer wastewater pipelines rehabilitation have been completed by using fold and form materials since 2018. 420 kilometer pipeline has been rehabilitated by fold and form until today in Istanbul. Before the rehabilitation, the line is cleaned and its images are taken and inspected to understand if it is suitable for coating before rehabilitation. They are used regularly not only for the rehabilitation of the lines, but also for the maintenance repair determinations. You'll see 5 studies at first, at the beginning. The most important issue for us is occupational health and safety. Coating manufacturing process with fold and form technology. At first, the metal is softened by heating, and then the softened metal is pulled into the line with the help of a crane. Reheating in the line, reheating process started in the line. Pulled material is inflated in the line with the help of a high pressure and heat. And then after the inflated PVC pipe is taken to the rest and cooled. In this way, rehabilitation and cooling process is completed. After that, connections are properly cut after coating. It's about milling videos before rehabilitation, milling the concrete and the 3 rows, the second, as you see. And I can work the other side after the rehabilitation, connections, reopen, supply the service. And should be cut properly after the rehabilitation. It's important, really. If we show summarily the rehabilitation with fold and form, as you see, it's before lining of material, second stage, and third stage, inflating of the material into the line. And after then, the rehabilitation, as you see, and the connections properly cut open. We have nice studies. This is an example from our nice studies. Sometimes we are not, we couldn't stay in the morning, during the day because of the heavy traffic, especially Istanbul. As you know, situation about Istanbul. Istanbul Island District, we have 4 districts. This is the natural site. And Büyükada, Kınalıada, or Heybeliada, Burgazada, totally 24.4 kilometers has been successfully rehabilitated by this technology. This is the Grand Bazaar, and also famous historical places, Grand Bazaar, is successfully achieved the rehabilitation of its lines at the night again. At the stage before the condition, before rehabilitation, after cleaning, and after rehabilitation of the Grand Bazaar. Yes, you see the technical specification and standards of the material. We have to construct by this using the standards and specification, of course. Tests are performed on the sample material and the results are reported. Sample is taken from wastewater, any proper manhole. Now let's watch some problems solved. At first, this is an example of fractures and cracks problem on the lines. Before the rehabilitation, after the rehabilitation. We want to share our experience, by the way. Second is problem solved in dance and collapse. Good example for the material to show the strength and resistance. Because of not excavation, so that we solve the problem with trench technologies. Problems of corrosion and the base leak. For leaking to the wastewater line and solve the problem of corrosion. A good example for prevention of flattening in corrugated pipes. Even after the roots can affect the flow, this can cause line of the problems, of course. First, the 3 roots in the line was cleaned by milling. Then the rehabilitation process is completed. Maybe the natural sign, green zoom. And another example, 3 rows. A good example for preventing water entry into the existing line. Sometimes we can encounter these problems in the sea or near the river sites. Hızlı. A good example for preventing water entry into the existing line. Sometimes, Gördük değil mi onu? Bunu gördük değil mi? Pardon. Heh. At the last one, good example for showing the material's flexibility. We solve the actual slip. Incentive and domestic fall and fall material production. We achieved the domestic fall and fall material, and all three stages and procedures you'll see. Our administration starts are the activities in 2018 with İSKİ and Kanaltek company to produce PVC fold and form technology in Turkey. Samples, production stage, test and test results, fold and form rehabilitation materials which were started in 2018 and successfully completed in 2018 by the cooperation of İSKİ Kanaltek, were sent to the Minister of Industry to make it included in the scope of domestic goods. Application have been made and all processes have been positive. We have successfully manufactured the production of the domestic material and start to use it. Yeah, the other one for the rehabilitation technique, cured in place pipe, CIPP UV technology. In the European site, since 2018, 140 kilometer length of wastewater lines rehabilitation was completed by using CIPP UV. Since the cable of the UV light during curing devices is more than 200 meters, maximum 200 meters of curing can be done at once. Plants with CIPP material into the pipeline, as you see, and then making curing with UV lights. All stages of the curing process are controlled, and at the last, curing with UV is completed. If we show summarily the rehabilitation with CIPP UV before the line, placing material, third stage curing process, and after the curing. This is the example from our non-circular pipeline projects, as you see. The large diameter lines, CIPP UV technology applications, larger than 600 millimeters. Sometimes we need the rehabilitation at the larger diameter. Technical specifications, standards, and test results of the CIPP material. Pressure pipe, potable rehabilitation. Process of using hose liner, or the other name, previous line. First stage is the deactivation of the line. Second, cleaning and milling the pipeline. Third, pipeline inspection. And at the last, placing the hose liner material. At least we complete it by taking the line into the operation. With this method, rehabilitation of 400 millimeter diameter and 86 meter length PN 16 pressurized drinking water line has been completed. This is the Kayırtal Pipe Bridge Crossing project. We began to use this technology, hose liner technology, and all concerned states are the follows. The current situation, as you see. Economic and physical life were lost. Before cleaning, into the pipeline, as you see, and after cleaning, and the last one, pulling the material. The other example, transmission line located on Haydar Aliyev in Sarıyer district was made with this method. This project is PN 16 pressures drinking water line with 300 millimeter diameter and 250 meters length. Planning and investments for the rehabilitation of pressures lines will continue. Innovative application of water and wastewater system. This is hot tapping technology. With this method, we perform the operation of placing valves in the existing drinking water network lines and taking branch from the existing line network lines. Due to hot tapping technology, water kite is minimized during maintenance works in Istanbul. Since 2018, there are a lot of waves and getting branches working. As you see at the screen, we are using now new installation techniques at İSKİ. These are horizontal directional drilling, HDD, micro-tunneling, pipe checking, and also tunnel boring machine. All of those systems are being used for potable water, waste, and storm water pipelines. Horizontal directional drilling, we prepare the construct of infrastructure for passing the special areas as follows: high traffic, high underground lines, facilities, historical places. We have a lot of historical places, natural size zone, a crossing river, a crossing railway and roads. Since 2018 today, 7 kilometer pipeline has already been installed with HDD technology. Until today, 50 kilometer pipelines has been already installed with HDD technology. Construction stage of HDD technology at first, quiet drilling stage, welding process of the materials, and reaming the diameter, and the last pipe pulling. For example, this project is 400 millimeter diameter, 450 meters long, and was completed with HDD techniques because of the open excavation couldn't be done on the sandy land grounds. All pipes were pulled at once with HDD horizontal directional drilling. And also, while the bentonite used during tunnel expansion and pipe pulling, soil improvements has also been achieved. Tamam. Another project, HDD, and also some give example about the tunnel construction and innovations installation. The collected sewage is transported to wastewater treatment plants through tunnels with a diameter of, as you see, at İSKİ, the first project has been using the tunnel boring machine, is not golden horn tunnels, was completed in 1997. There has been approximately 200 kilometer long wastewater tunnels and 5.6 kilometer long stormwater tunnels in Istanbul. There are total wastewater and stormwater line project is planned with a length of the 120 kilometers throughout Istanbul. This is the Ayaza project. The tunnel project is 3,600 millimeter diameter. Excavation, tail tunnel excavation, and then TBM montage process and establishment of ring. Tunnel construction process with TBM. storage area and work sites and segment manufacturing area. This is the very important, another very important our projects. Problem, after heavy rains in Üsküdar district in recent years, flooding the Üsküdar Square. So we have built two different rainwater tunnels. With this project, the regeneration of Haliç Golden Ore has been provided by transferring the fresh sea from the Bosphorus Sea. This is the big project. Also, the length of segment drinking water tunnel with inner diameter of 4,000 millimeters and is more than 20,000 kilometers. Is aimed to convey the melon water brought to Kağıthane district to the inner and western part of the European side of Istanbul. Pipe checking. Only one or maybe two example. The MM 400 millimeter inner diameter concrete pipes are used in this project. Total length of the project was more than 3,000 meters. The sewage collector project is constructed alluvial sand soil parallel to the Bosphorus Straits and below the ground water table Göksu River, and this is the Bosphorus. And also another project is the Tuzla project. Tuzla CD shards with a diameter, as you see, and length more than 2,000 meters. It's finishing. Our administration, İSKİ, has been awarded 5 stars in the AFKM Quality Congress organized by Turkey Quality Association. İSKİ has been awarded 11 ISO management accreditation certificates. Thank you for your listening. Two video only.
Maybe after the presentation.
Okay.
Dr. Kadir.
Pardon. Aldık mı? İyi.
Can you okay, close it? Good. Yeah. Okay.
Good morning. My name is Otto Ballantijn. I'm the CEO of Reduct. We're based in Belgium. First of all, I would like to thank the organization for being able to bring this speech to you today. Hopefully you will learn something and to be here in this beautiful country. I'm going to be talking a little bit about inertial navigation, using inertial navigation to obtain pipeline information, particularly location, and I'll start off straight away. Reduct started over 20 years ago building inertial navigation mapping technologies. I will explain what it is. Currently, we're pretty much the only ones in the world who do that for domestic pipelines. And we're based in Belgium, and we basically do that for all types of utility pipes. This picture is my favorite picture I ever found. It's actually on a job site. it explains a little bit why you need accurate data. If we ask the utility owners of these pipes to give the map of this particular area, you will see perfectly parallel pipes. When you open the ground, you see spaghetti. Yeah? So this is the reason why having good data about where your pipe is actually quite important to maintain the integrity of your infrastructure. I'm going to explain a little bit about inertial navigation. This is not a tech talk. If you want a tech talk, we are in booth 33 and we'll tell you exactly how it works, except for the patents. But fundamentally, an inertial navigation system travels through the pipe and it basically records its center axis, which is indicated here by the red arrow. That's what it measures. And it measures the changes it makes in heading. It measures the changes it makes in the pitch inclination, its own roll it measures, and in our case we have some odometers that measure the distance traveled. Now, the interesting thing about this technology is we do this at 100 times per second, which is different compared to any other technology for locating pipelines, where you maybe have a point per meter, 2 meters, 5 meters, depending on how you do it. We have 100 samples per second, which basically means a sample per centimeter. I will get into a couple of case studies why that is important. So in the end, when you pass an inertial navigation system through a pipe, you get a map, a three-dimensional map of where that infrastructure is. We link that to the GIS by giving, whoops, oh, this is a pointer. No, it's not. Okay, anyway, we know the endpoint coordinates, we tell the software what the endpoint coordinates are, and the entire line is given in your GIS platform. 10 minutes after the tool comes out of the pipe, you can see your results in Google Earth, AutoCAD, Esri, you name it, it's open platform. Now, what are the advantages of this type of technology? You can apply it in any utility. It doesn't really matter whether it's a gas pipe or a water pipe or a wastewater pipe or a data duct. Any duct or any conduit from A to B can be mapped. Also, the pipeline material is irrelevant. Even in steel pipes, where a lot of technologies have a problem because of the Faraday effect, we have no problem with electromagnetic interference or being in a steel pipe. We don't need to trace the tool as it travels from the entry to the exit point. So we can cross highways or rivers. We don't care where the tool is at any moment while it's traveling. All we need to know is where does it go in, where will it come out. So that's a big advantage over traditional locating technologies. And as a result, we basically can go to any depth. If we have a horizontal drilling that's 50 meters deep, we'll go 50 meters deep. That's no problem for our technology. It's watertight anyway, so we can go quite deep with it. As I said, it's not affected by electromagnetic interference, and this is a key difference with a lot of the other locating technologies. We can map underneath rain tracks or near metal sheeting, right next to high voltage power cables, no problem. It doesn't affect the result at all. And one of the secondary key benefits is the number of points that you get. When you use a traditional surveying method, displayed here at the top, you may get a point every 3, maybe sometimes even 10 meters, depending on how it's defined. Now, what can you do with those points? Yes, you can make a map more or less where the pipe is, but for the rest you can't do anything with that data. It just tells you where the pipe is. If you get high frequency points, which is depicted in the lower picture, you can already see that those points actually follow the small differences in shape of the pipe much better than the top does. Yeah? I'll get into this with my case studies because that's really interesting to see how that can help you improve the management of your network. As I said before, it's completely open platform, so whatever platform you use this data, or you want to use this data in after the investigation or the mapping, it is open platform. There is no requirement to purchase anything or do some manual conversion from our output to your input. And that's key because we all know As soon as people start touching something with their hands, that's where the problems start. So the reason why you want to do this is, first of all, you want to feed your GIS platform with accurate data. But more importantly, and we see this in many countries where we've started 10, 15, 20 years ago, it has become the judge between you as a utility owner who writes the tender and the contractor who does the work. No longer will you receive an as-built from the contractor. You have an independent method of determining the results of your specification. And that is very important, particularly in places, in tenders where you have defined a minimum bend radius. Well, you know what? A contractor is not going to tell you that he didn't make that. He will give you so few points that you can't calculate it. Or in the wastewater industry, if you have an inclination grade, if you have a gravity sewer, and you have specified an inclination grade, this technology can give you a very accurate output as to whether that was made or not. And then one of the case studies will go into this. For existing pipelines, of course, you know, you upgrade your, I don't have to, the number of utilities I talked to yesterday and early this morning already who said, our maps are not very good. Well, that's not a problem of Jordan or the Middle East. That's a global problem. Wherever we go, maps are old. And that's nobody's fault. It's just the technology wasn't there at the time to do better. But now we're stuck with it. So if we can upgrade it during maintenance, great. So we're going to talk a little bit about high frequency and how that helps you manage your network better. Of course, as I said, the primary function of the tool is to create an as-built map, but the high frequency gives you additional opportunities to learn more about your pipe. So when we look at traditional surveying, whether it's with a walkover system, a beacon system, or what have you, you can basically get a point every 3 to 5 meters, and any infrastructure that's deeper than, well, depending on which manufacturer you talk to, but let's call it 10 meters, you can't see anyway with a walkover system. Our technology travels through the pipe and creates a point every centimeter. And that's because of the logging rate being so high. So let me explain that in 3 case studies. First of all, we're going to look at a data cable, HDD. We're going to look at a damage that was done to a large water main that nobody could find with sort of standard technology. And we're going to look at the gravity sewer, as I said earlier. So let's look at the data cable first. So we have the typical manhole of a data manhole where your typically 50 or 40 millimeter ducts end up. And the red line is what the owner of this duct had in his GIS platform. And this is an old horizontal drilling. Now he already knew that his line was incorrect because the yellow arrow shows where the pipe was coming into that manhole, and the drawing says it comes into the side, but he knew already it's not coming into the side. So he figured that they must have drilled something like this, but he had no idea. Yeah? Well, we passed our tool through, and that's really how it went from A to B. So basically what they'd done is they drilled underneath the canal to the parking lot and then dug a trench back to the road. Yeah? Now, why is this significant? Well, first of all, because it's blatantly wrong, but imagine you work with this data and they're going to do some work on that parking lot, build a building or something. And they ask you, is your infrastructure there? And they look at their GIS platform and says, nope, we're closer to the canal. But in fact, you're in the middle of the parking lot. Now, interestingly enough, this is 2013 when we did this particular job, and this is today. They build a building there. They're working on the parking lot, yeah? Had they not known that, they probably would have cut that cable. It was actually a bundle of cables many, many times, yeah? So that's why knowing where your infrastructure is key in being able to deliver the services that you deliver going forward. The second case is an interesting one. This is closer to home. This is a water main in the Netherlands. And the situation is as follows. The Netherlands, as you know, is built below the sea level. I don't know why. I'm Dutch myself. Why couldn't we find a place with a mountain? No, we're going to live below the sea level. And in order to do that, they built dikes. And the road you see there is one of a dike. And where that white patch is, the dike was sinking away. It was degrading. They knew there was a pipe underneath, but they wanted to know, is the pipe the cause of the degradation of the dike? Now the problem in this case was that it was waterlogged, it was full of water, so cameras couldn't go in because they couldn't see anything, and there was no other way of figuring out how to do that. Furthermore, there was only one access point, which is at the bottom there, and at the top end you could not get into the pipe, because this also happened to be an old horizontal drilling. So if we look at it from street level, you clearly see the patch in the road where they repaired the dike, and the line in fact is the result of what we measured from the top view. So our tool went into the pipe. But let's talk about how we did that. So just to say, you know, what is our focus of interest? It's not the whole result, because they knew the pipe was there. Actually, their map wasn't that bad. But they wanted to know what happens between meter 79 to 90. That's what we're interested in. That's where probably the issue is. So as you can see here, this is the pit that they dug, and you can see the very unclear, but you see the access to the pipe, which is already underwater because of the high level of the groundwater. Yeah. So that's where we had to go in. Now, we only had one access point, and normally we pull the tool through, but in this case we couldn't do that. Plus it was full of water. Our solution, let's use an ROV, a submarine. So we built a little stick on our tool that the ROV could grab. We lowered the tool into the pipe, we lowered the ROV picked up the tool, and it swam, basically the tool, 160 meters into the pipe, and then let the tool go. We pulled the tool back, and that was our measurement. Let's look at the results. So here you see the results of the depth profile. We're only interested in the depth profile, because that's where any breakage of the pipe could be detected. Now in this case, you see we mapped 165 meters. We're only interested in the 76 to 90 meter area, so let's focus on that area. Let's zoom in. Now be careful. The horizontal axis, the x-axis is in fact 14 meters. The y-axis is 40 centimeters. So we really pulled the picture like that just to show you. Also, this picture gives you a 3 meter point interval. This is the picture when every 3 meters I have a point. Do we see something exciting? Nothing, right? Nothing. I don't see anything exciting here. So let's increase the frequency of this measurement. Let's go to a 1 meter interval. Now all of a sudden we start to see something happening. So particularly in that one point there, over 1 meter the pipe is actually dropping 6 centimeters, which is not definitively a break, but given that this is a horizontal drilling, it's unusual. You can't drill like that. You drill much more gradual. So, but still this resolution doesn't give us the answer. Is there a break or not? So let's go to 10 centimeters. And now all of a sudden we see that the tool dropped about 2 centimeters at that point. Now we now know for sure that you cannot horizontally drill, so the pipe is definitely shifted there. Yeah? In fact, we found 2 more spots towards the end where the same phenomenon occurs. Now, as a result of this measurement, which took an hour and a half in total, lowering the tool in, putting the ROV in, swimming it in, pulling it back, analyzing the data, 1 hour and a half. And this problem was on the desk of the engineer for 8 months, and he didn't know how to solve it. And the dike was sinking. So the outcome of the survey is that the divers went in and they fixed it temporarily, and then they made a new HDD to replace the entire pipe segment. So that's the way in which high frequency created a solution or gave the solution to something that no other traditional technology could give. So let's go to the third case, assessing the grade of a sewer. Now this is a gravity sewer. Oops, let's go back. Oh, back. There we go, sorry. This is a gravity sewer segment. There's many different segments, as you can see, and they go from manhole to manhole to manhole. So this is about 1, 2, 3, 4, 5, 6, 7, 8 segments between manholes. Nothing really exciting. It was a gravity sewer. It had to be on grade. But as you can see from the picture, it's done outside of the urban area in very soft ground. And the owner of the sewer was worried because they opened the ground, put the sewer in. That was not done by HD, it was just an open trench. And then they measured it with standard GPS. And it looked good. But then they backfilled the ground and they drove over it with heavy machinery. And now all of a sudden the owner said, yeah, but has that moved my pipe? You driving over my pipe the whole time with the machines and stuff. So they called us in and said, can you assess a couple of these segments to see if they had moved? And because there was a before they covered the ground, it was clear that it was nicely on grade. Well, because I'm giving you this presentation, you may already guess the answer. So we pulled our tool through, and the blue line is the depth profile of that particular sewer at a frequency of 10 centimeters. So the picture here is a bit shifted, but this is a 10 centimeter point interval. So the depth profile is the blue line. You already see at some point it's actually going up. But our software gives you green and red bars to show you exactly where inclination is positive or negative. And of course, positive inclination in a sewer grade sewer is bad. Negative inclination is good. But there's lots of spots where this pipe is no longer flowing downward. Is that bad or not? That's not for me to decide, that's for the owner to decide. Yeah? But it clearly is not on grade. Now let's see, and I apologize for the numbers shifting, but the arrow is going to move over one, and it's going to the 1 meter interval. So if I only had 1 point per meter and not per centimeter, this is what I would see. You still see at the bad locations, the significant locations where the pipe is shifting upwards, but it's already a lot less detailed than at the 10 centimeter interval. Let's move it to the 3 meter interval. At 3 meter interval, it almost looks like it's perfect. If I'm the contractor and I had to give the as-built on this one, I probably say 3 meter is a good one, yeah, for me. If I go to 5 meter, all data significance is lost, yeah? So here is a very clear picture, and we'll show this one more time more quickly. Look at it a bit faster. How quickly your resolution disappears as you increase your segment length, yeah? So that is the significance not of creating an as-built, but creating rich, high-frequency data to better manage your network. Of course, our core business is to give the owners accurate as-builts. But we can provide bend radius, we can provide inclination information, we can do it all. We can make sure that the specifications that you have given to the contractor are met. And how you deal with the outcome, that's up to you. Yeah? You can say, I have a financial penalty, or the contractor has to redo it. Whatever is up to you, but at least you have the information. And with that, I thank you very much. We are at booth 33 behind us. If you need more information, would like to see a little bit more about the tools, we have a couple of tools laying around there. You're very welcome to come around. And I thank you for your attention, and if there's any questions, please ask after the next presentation. Thank you.
our third presentation will come from Mr. Mohammed of Hereknet Company, located headquarters in Germany. So Hereknet is one of the largest TBM manufacturer. So please.
So, hello, ladies and gentlemen. I'm Mohammed Shahata from Trenchless, Germany. I'm very happy to be here for the second time at Trenchless Arabia and present something about my company, Trenchless. So, thanks for Mr. Abdelkadir, Mr. Otto for their nice presentations, and I hope I can still have time for my presentation too. Today I'm going to talk about large diameter and long distance drives, latest trends in slurry pipe and jacking. Some few facts about Trenchless. It's located in southwest of Germany in the city, very small city called Schwanau. We have around 4,000 employees, and we make around 1.18 billion euros for output, 1.14 revenues in 2021. And this is our headquarters. It looks very nice, but only in summer. In winter, it's very cold. So, our solutions are mainly in the field of traffic tunnels, utility tunnels, mining sector, pipelines, exploration, shafts and foundation, which mainly anything that includes to underground excavation. So these are our machine portfolio that should fit any underground excavation projects with whatever parameters are required. We can find a solution in our machine portfolio for that project. So we have around 1,200 TBMs for traffic tunnels, when I say traffic tunnels, it means they're talking about 5 meters and above. The largest machine, what we built, was 17.6 meter in diameter. It was a project in Hong Kong. We did also the 19 meters machine design. It was a project, I think, in the 2005 in Russia. We did the design, but the project was for somehow canceled after that. So still the biggest machine that's ready to implement the project is the 17.6 meter diameter. So when I talk about that we have 2,000 machines, TBMs for utility tunneling, I mean with utility with the diameter starting from 5 meters and less. The smallest one is 250 millimeters. It's mainly used for internet cables and so on. So in the tunnel and shaft sector, we have applications for sewage stormwater, as Mr. Abdul Qadir explained in Istanbul, water and desalination plants, and also shaft sinking. In the sector pipeline, we have the application of oil, refineries, gas, LNGs, hydrogen, carbon, whatever related to a pipeline. And in the energy sector, we have this new application for our technology is the offshore foundation. It was a project last year in France. They want to build a wind farm in the sea. They were unlucky to face a very rocky seabed, and they came to us. We thought about solution just to make a place for the foundation of the wind farms. It was very successful. It was our first prototype to drill vertically in the seabed underwater. Also another applications for the energy sector is the hydropower plants, grid connection transmission, and district heatings. So for this application, we have this machine portfolio. I'm not using this. So we talked today about utilities. So we have utilities, either a tunnel or casing or a pipeline, wherever, how is the product that will pass through the tunnel should be done. In the utility tunneling, we have, as I said, from 4.8 meter diameter till 0.25. We have the micro-tunnel machines, micro-tunnel boring machines, or pipelines, or also plastic pipes. So these are the body of the tunnel that should be excavated. So we're talking today about pipe jacking and segmental lining for supply disposal infrastructure. Here's how it looks like a job site. On the left-hand side is the pipe jacking job site, and on the right-hand side is a segmental lining. The difference is how you build the body of the tunnel, either already with precast concrete pipes, and you just jack one pipe after another. So you, at the end of the day, you're moving the whole tunnel from first pipe till the last pipe. The second type is the segmental lining. You just build one ring behind the machine, and then you proceed further to make a place for the second ring. So these are the two types for the pipe jacking or segmental lining technologies. We have different soils. This is the biggest challenge that we face because normally we are controlling the machine from above the ground, and the machine is excavating under the ground. So I need to have enough information before my machine goes down, because the machine is going to deal with the type of soil what's in underground. So either we have the slurry mixed TBMs for a specific soil, also for the EPB technology, the earth pressure balance technology, a little bit with clay, and also the rock ground conditions. We have specific specifications of our machine that fits the type of the soil that we're facing. So these are the three types of machine. The AVN is the slurry machine, and the EPB is the earth pressure balance machine, and the TBMs, mainly for rock. The first thing that we have to know about the geology, the type of the geology, to be able to decide which type of the cutting head to be used. Either I use a soft cutting head, or a mixed ground cutting head, or a rock cutting head. So these are the, and you can see the difference between them is mainly how many cutting discs I have on the cutting head, also the percentage of the openings on the cutting head. This is related to the type of soil what we're facing. That was, I thought that the video might not work, so we'll try at the end of the presentation maybe. But this is how the job site for a pipe jacking looks like. We have our shaft, where our jacking cylinders, the main jacking cylinders, waiting for the machine to push it inside, and then we bring one pipe, jack it, and then move forward, and then the second one, and so on. So this is the machine. We have, at point 1, we have the cutting head, and then at point 2, we have the main drive of the machine. Point 3, we have the steering cylinders, because our machine can also excavate with some particular curves. Number 4 is the telescope station. It's an additional source additional force just behind the machine. As I told you before, in the pipe jacking, we're moving the whole tunnel. So you need more force whenever your tunnel is becoming longer. And if you need more force, then you can consider this telescope station. It's located just behind the machine, and you can open the cylinders, so increase the force only be transmitted to the machine. Number 5 is the intermediate jacking station. Also, this is very important if we are talking about long distance pipe jacking. So either to move the whole tunnel from the main jacking station, which is number 6, we can have also this intermediate jacking station, which is number 5. So I can just split the whole tunnel into 2 tunnels. So I push the left part only from the interjacking station, so I need less less forces compared if I'm moving the whole tunnel from point 6, which is the main jacking station. So we have also a navigation system in our machines, just to know where is our machine, how are we excavating on the right track or not. It depends on the whole maximum drive length, so we can use the appropriate navigation system for this. We have what's something new since last year. We introduced the Herrenknecht Connected. It's a software that connects your machines with your computer, your laptop, your mobile, where you can check live the whole parameters that your current machine is working. It's not only for one machine, it's for your whole fleet of machines that's excavating right now. So before, the tunneling manager used to drive from job site 1, take the parameters, then drive to job site 2, take the other parameter, and so on. So he lost his day just traveling from one job site to another just to collect the data. With this software, you could do all of this just from your office. So some reference projects we had. Now we're talking about the long distance pipe jacking. So very important tools to consider for long distance pipe jacking is the lubrication system, because as long as your tunnel is getting longer, so which exactly automatically means your friction force is getting also higher. Yeah? So you need to make sure that your lubrication system is working efficient, very efficient, just to reduce the friction force so you can able to go for a longer distance. Also, what's important, just explained a few slides back, is the intermediate jacking stations, which means I just split my tunnel into small sub-tunnels, and I push these sub-tunnels using the interjacking stations, instead of pushing the whole tunnel from the main injection station, from the launching shaft. So some reference projects was in Altamira landfall in Mexico. We had a tunnel length of 2,246 meters with an AV&D 2000 machine. It was an extended machine. We had a groundwater, we had a geology, very, very important information for me before I select the appropriate type of machine. We had a sand, silt, and clay. Groundwater pressure was also a 3 bar. So we have recommended to use the AVND, and D stands for the D mode. This D mode, it's basically the same concept like the earth pressure balance. You can just balance the pressure coming from the soil facing the cutting head. We just try to balance this pressure so we have an equilibrium state between what's going inside the machine and what's coming from the ground facing the cutting head. This is one of my favorite topics or type of projects I love to present is the sea outfall drives. This mainly in the application for desalination plants, and also I think in our Arab countries this is very important. Countries like Saudi Arabia, for example, they live on desalination plants. They have no rivers and so on, so their main source of water is the desalinated seawater. So what you do, you build your desalination plant somewhere onshore, and then you need to bring the highest quality of water, of salt water from the sea. So you make this through a tunnel, just build a shaft where near to your desalination plant, and then build a tunnel from your desalination plant, goes up to the point very deep inside, very far inside the sea. You get the highest quality of salt water. So you need less process of cleaning the water, and you can start directly your desalination process. So it's a normal AVN machine. It's a normal slurry machine, for example, but what comes extra to this machine, so that because the machine will have no a receiving shaft. It will be it will come up, it will have, the line will have this banana shape tunnel, and it will just come up from the seabed. So we add this recovery module for our machine so we can get the machine outside from the seabed. We had this project last year in Kuwait. It's Hayman seawater wastewater treatment plant. It's the second application for the outfalls. You have your treatment plant, you treat whatever wastewater you have, and then you have to bring this water somewhere. Some people, some countries, they just bring it back to the sea. So you need an outfall. It's the same concept. So we had an outfall tunnel of 1,960 meters. We had geology sand, silt, with maximum 64 megapascal for the UCS, and we have a 47-meter daily. That's what the best daily performance, and we have a weekly best performance for 237 meters. Same project. This is also a seawater intake and also an outfall. Was in Ghana, in Africa. We have an AVND 2000 machine, also with this recovery module, because it will be also recovered from the seabed. We have 2 onshore tunnels, 545 meters, 520 each, 2 offshore tunnels, 380 meters, 1,085 meters. It was for the power plant cooling water intake. So another application, they have a power plant where they have to cool it using water. So they have to bring the water to the cooling plant. They did it through underground. It's an underground tunnel anyway, but it's underground under the seabed. That's the difference. This was the project in Ghana. This was our launching shaft, and the receiving shaft was simply through the seabed. So back to the large diameter application in pipe jacking. We have more than 150 large diameter project. I mean, with large, I mean over 2.5 meter diameter, ID. We have over 90% with slurry machines, this large diameters machine. So, for example, in Saudi, we have in Jeddah stormwater projects. They also want to collect the stormwater. They have sometimes they have very heavy rainy seasons. We have a total of 8 kilometers of stormwater tunnel done by pipe jacking technique. We have 2 machines, one with the AVN 3500 in diameter, and the second one was AVN 3000s. Another big project was done in Buraida, in El Qasim region, also in Saudi. It's a little bit bigger project, in total of 22 kilometers. We have around 7 machines working with the large diameter long distance pipe jacking. It was AVN 3500, the in diameter. And we had, we were working at a depth of 52 meters underground. We have a very, very abrasive soil, sand, clay, up to 2 bar groundwater. So this all has to be known before our machines start, or our client machines start to excavate, just to have the appropriate consideration for this. This was in Buraida, the 3500 machines. So, second, or another large diameter pipe jacking was in Vancouver, in Canada. We have an AVND 2500 with an extension kit, so it was working an AV for 3.5 inner diameter pipes. We have a tunnel length of 800 meters. Maximum drive length was 365. We have a geology mixed ground, gravel, boulders, and these are not lucky to face, the boulders and the gravels. This project got an award in NoDig Calgary in Canada, because it was, I think, the first time to use this large diameter, the 3.5 with 4,200 OD outer diameter in Canada. Because previously was the concept of the pipe jacking in the understanding of some people limited to 2,000 ID, 2,000 meter, 2,000 machine, 2.5, but larger than this was always considered, let's do it segmental lining. But we proved that pipe jacking can be also done for longer distance and also for the diameter 3.5 in and outer 4.2. So another project was in Thailand. It was also a sea outfall tunnel. So you can see in this, on the right down picture is the recovery of the machine. The machine came up from the seabed, and then it was recovered with a traverse or with a crane. Some divers went down there. They just connected the machine with the crane, and then it was recovered from the seabed. And the machine was, well, will not be flooded. It will be completely sealed so that you can have your machine back with no damages. So some other applications, mainly for pipe jacking, it can be said that the sea outfall offshore recovery of the TBM or the micro tunneling TBM, or also the pipe arch, where you can just make an arch of small diameter pipe jacking, and then you can excavate whatever under the arch is. Cross passages is also done in Hong Kong, where you have 2 large diameters tunnels, so car tunnels, one for going and one for coming back, and you just need to make this emergency connection between the 2 tunnels. So we do it also with the pipe jacking. We excavate from one tunnel towards the other tunnel. And also we have some very special applications for pipe jacking, which is the blind hose. Normally tunnel have a starting point, ending point, that's it. But sometimes it's needed to have a dead end tunnel for storage, for example, or something like this. Thank you a lot for your attention, and I'm very happy to receive some questions. So maybe later.
I would like to thank all of our presenters. They really did wonderful presentations. So now we are in the question and answers phase. So I would like to ask any one of you who will raise question. First of all, introduce yourself and your name, your company, and which country you're from. So anyone want to ask the first question? Yes. Please wait for the microphone.
Good morning, and thank you all for the amazing presentations. There are a lot of data. There will be many questions, I'm sure. So my first question is to Mr. Abdul Qadir regarding the horizontal directional drilling for installation of new pipes in a city, crowded city like Istanbul. Number one, what is the pipe material that you pull? Number two, what is the length of each section? My other question, if I can go, or shall we wait for, is to Mr. Mohammed Shahata, regarding the pipe jacking. For jacking a pipe, diameter 2000 internal, 2000 millimeters, for a length of 3 kilometers, approximately, what would be the cost per meter? Thank you.
We use the high definition polyethylene materials for the HDD technology. And also 5 or 400 meters lengths we achieved 100 millimeter diameter to the 600 millimeter diameter. Our project is continues to today, until today. And the other material we don't use right now. Only the high definition polyethylene. How long? Especially more than 400 meters.
400?
Yep.
One section?
One section, yep. Mm-hmm. Yes.
Hi. Thank you for your question. I think maybe I forgot to explain this at the beginning of the presentations. We are just a machine manufacturer. We are not a contractor company. So we produce only the machine for you, for the contractors who then take the machine and do the job of tunneling. So cost per meter, I'm the wrong guy to ask, but maybe I can ask you if you are coming from the contractor background. What I can tell you after you give me the full information, what I need to recommend you the suitable machine for you, I just can tell you the price of the machine. But cost per meter, wrong guy.
Okay, could you please introduce yourself?
I'm sorry, I forgot. My name is Kemal Zobi. I am a consultant.
In Jordan?
In Jordan.
Okay. Yes. Okay. So let me mention for some of our audience in this room that Trenchless technology is environmental friendly technology. So there are some trenches renovation, rehabilitation solutions and trenches installation solutions. So we don't guarantee zero excavation, but we guarantee the minimum excavation. So by using these kind of technologies, for example, there are many advantages, especially in social effects in the community. For example, you don't create traffic jams. So you don't create, because there is no trench, you don't create any risk for pedestrians. There is minimum noise, minimum environmental effect. So there is minimum carbon dioxide emission. And it is fast. So it doesn't disturb your avenue, your streets. It doesn't disturb your business areas. So you don't have to transport the soil which will come out from the excavation. So there are so many advantages. And in many of the applications, people may not understand in the beginning, but at the last, when you make the calculations, it is more economic than open-dig traditional or conventional applications. So in the people's mind, they think that, okay, this is a technological solution. You need, machinery, skilled staff, but at the end, when you make all the calculations, then it becomes, more economic. For example, Mr. Abdulkadir, the first presenter, is from Istanbul Water Utility. Let me give a very quick information. At the time, I was a consulting engineer serving for that utility, and I made a calculation for them that if you make pipeline rehabilitation with CIPP or fold and form, and if you make the tender with this amount of kilometers, then you will save this amount of money. In the beginning, they didn't believe it, but they made a tender in 2017. The tender period or the construction period was 3 years, but the length of the pipeline to be rehabilitated is 100 kilometers. So after 100 kilometers, they made their own calculation, and they find out that they saved 30% of their budget by using trenchless solutions. So then now the utility is trying to make every installation with trenchless. They don't want to dig. This is very useful for metropolitan cities with high traffic, high density in population. So I'm sure that in this region there are very similar cases. So this is also, for example, in order to make any rehabilitation, you have to know where your pipes are. So you need to map it. You have to have a GIS system, and you have to know where your pipe, and then you have to check the condition of the pipe. But without knowing the location of your pipe, you cannot do anything. So it's just step and step. And also for, pipe checking. So I cannot think a world without, micro-tunneling boring machines or tunneling boring machines. It could be a nightmare for us for, long distance, large diameters, transmission lines, wastewater tunnels, utility lines. So this is very useful. And maybe, here there are some engineers or managers from water utilities, wastewater utilities. You may think that this is an expensive solution, but this is not true. It is not expensive. At the end, it is more economical than the solution which you are using until today. So I really request all of you, after this session, of course our time is limited, but please get in contact all the presenters to receive more detailed information about the advantages of Trenchless solutions. Okay, thanks for your patience for my words. And if you have, there is another question. Please do not forget yourself.
Good morning. I am Hussein Hajjat from micro-turning company called Adject Qatar. I have a question for Mr. Muhammad. For AVN 800, I hear that you had something like development in this machine in the speed of the cutting wheel, and you made something. This machine success or still not? I see this some videos for this machine, but I don't know what. And you try it somewhere.
Could you please repeat? Sorry.
AVN 800 machine.
Yes.
You made a machine with the high-speed cutting wheel, but I don't know if something happened for this machine. Is it success and it is working?
We had a development on the 800 AVN 800 machine to work, because this is a very small diameter, and you know that access doors inside the machine starts from the 1200 machines. So we don't have the option to go inside the machine and change maybe some cutting discs so that we can have a longer distance. So the excavating distance is limited in such small machines. So especially our challenge was to excavate the 800 in diameter in this very small inner rock geology. So our development was to have an AVN 800 hard rock machines that excavate in the hard rock with a little bit longer distance than the normal machine. This machine had a very successful project in Australia. But as you might know, it's not after one project you say it's a successful technology. It should be tested in different geologies, because I think that the rock in Australia is different than the rock in Medina, in Saudi, or the rock somewhere else. In Qatar also you have rock. So it should be more tested, but we believe that our machine can do the function for that.
Other question for this AVN 2400 or 3000. What development we need to do for the old machine to work in boulders? Is there a solution for this?
It depends on the size of the boulders you're facing. That's why when you tell me good morning, I need a machine offer, for example, I tell you good morning, I need the soil report. So it depends. Your soil report should also contains information about the boulder size, the particle size, and so on. Then we can try find a solution for that.
Okay, thank you.
You're welcome.
Any other questions? Okay, before closing this session, I would like to ask our presenters if you want to make any final comments. Okay. Then thanks for your patience, your time for attending this session. So I hope to meet all of you in the outside, in the coffee break area, to have a detailed discussion and to exchange more information. Thank you.